Welcome to question 2 of the 2009 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For part A we're asked to find an antiderivative of 1 divided by 1 take 2x with respect to x. And for the 2016 study design we're going to assume that x is greater than a half. So now what we're asked to find is the antiderivative of 1 divided by 1 take 2x with respect to x. And now if we take out the coefficient of x from the integrand, we could rewrite this as negative a half, and then we'd still have the integral of 1 divided by, but if negative 2 has been taken out from the bottom line, this becomes x subtract a half dx. And now we can find the antiderivative of this expression. It's going to be negative a half from the negative a half that's already out the front times log e of x subtract a half. And as we're only asked to find an antiderivative, that means that we can just let the plus c value equal 0. So that is a suitable answer for part A of this question. So only 1/4 of students managed to get the full marks for this question, leading to the examiner to say that this was very poorly done as a question. Most students realised that a logarithm would be involved in the answer, however few obtained the correct results. And for the study design that this was written on, students were commonly leaving off the absolute value operator. Now we didn't need to do that because we'd made the assumption that x was greater than a half, which meant that we don't need that part, but in the previous study design, it was required for full marks to that question. So for the 2016 study design, that question would need to be slightly tweaked to make it reasonable to be examined. For part B, we're asked to evaluate the integral between 1 and 4 of the square root of x plus 1 with respect to x. So that is equal to the integral between 1 and 4 of x to the power of a half plus 1 dx. And then if we use our knowledge of finding antiderivatives, we can evaluate that as being x, and then we add 1 to the power, so it will become x to the power of 3 over 2, divided by that new power, which is 3 over 2, and then plus x. And that's still going to be evaluated between 1 and 4. And then if we clean this up slightly, that would be the antiderivative inside would be x to the power of 3 on 2 divided by 3 on 2, would be the same as 2 and then times x to the power of 3 on 2 over 3. So instead of dividing by the fraction, we multiply by the reciprocal. And then we'll still have plus x between 1 and 4. So to evaluate this, we're going to sub in the upper and the lower terminals. So if we sub in the upper terminal of 4, this becomes 2, and then it's going to be multiplied by 4 to the power of 3 over 2, divided by 3 plus 4, and then we subtract away the antiderivative evaluated at the lower terminal, which is 1. So that's going to be 2 times 1 to the power of 3 over 2, all divided by 3, plus 1. So 4 to the power of 3 over 2 is the same as 4 to the power of a half, and then to the power of 3. But the power of a half is simply the square root of 4. So the square root of 4 is 2, and then we raise that to the power of 3, which gives a value of 8. So our next line of working becomes 2 times 8 divided by 3 plus 4, but we're going to write that as a fraction over 3, which would be the same as 12 over 3. And then we'd have minus, and 1 to the power of 3 on 2 is simply 1, so we're going to have minus 2 on 3. And then we're also going to have minus 1, which we can write as minus 3 over 3. So evaluating that, we'll have 16 plus 12 is 28, minus 5 is 23, all divided by 3. So that is the value of this definite integral. So for part B, around 50% of students got full marks, with another third of students getting 2 marks. So this question was quite well done, with most students being able to anti-differentiate and then set up the solution with the appropriate limits. A stumbling block for many students was not being able to evaluate 4 to the power of 3 on 2, as we showed on the previous slide, or alternatively, students could have interpreted that as 4 to the power of 3 and then take the square root, which would lead to the same answer of 8.